To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So, my dear children, in the earlier chapters, we discussed about several things regarding the nanotechnology lesson part. Over there, we discussed about the area and the volume of a certain nanoparticle. What will happen to the surface area, right, when minimizing the size of the particle, or when during the reduction of the size of the particle, what will happen to the surface area and what will happen to the volume. So we have discussed those things in the previous chapter, and from that, what is the benefit that we can take? So let me remind you about the volume and the area from the previous chapter. So in the previous chapter, when you take the area and the volume, when you take a certain nanoparticle or else any kind of a particle, even though its area is getting increased when minimizing the size of the particles, the volume is constant, within a constant volume. I mean, like, if we are taking one cubic centimeter of a certain substance, then after reducing the size of the particle, in simple, my dear children, you take 1 gram of, you take 1 gram of salt crystal that has a 1 cubic centimeter of a volume. You crush it into pieces or else powder, a thin powder. Then if you measure the entire mass of it, then it's equal to 1 grams. There's no difference in it. And the other thing is that if you measure the volume of that certain powder, right, it's also equal to 1 cubic centimeter, which is the same as the initial crystal. But however, what's getting changed here is the surface area. Surface area is dramatically changing in here, my dear children. Okay. So always remember, when you take a certain substance, right, if you reduce the size of it, that means if you can cut it into several pieces, even though the volume is not changing, even though the volume is a constant value, the surface area of the substance is keep getting changed, right? Here keep getting changed means smaller the size of the particle, surface area is reduced. When surface area is increased, not reduced, surface area is getting increased. So when increasing the surface area, what will happen? Right? Always remember, smaller the size of the particle, higher the surface area. I'm just talking about here cutting or separating a certain particle into smaller pieces, okay? Not just a one single piece, but all of them collectively, right? So when increasing the surface area, what will happen? The reactivity of the substance is keep getting increased, okay? That's why even the gold, which is an inert substance in our normal room temperature or in our normal environment, okay, so it is inert. You know that gold is showing the luster for very longer time period. I mean, like when you take like 5 to 10 years, even way more than that, right? The glitterness of the gold is not getting faded. It's not getting tarnished that much quickly. It's because it is an inert substance in the nature. Okay, in our normal environment, it's an inert substance. It's an inert metal. Okay, so therefore, my dear children, it's not going to react with oxygen or any other substance in our environment. So the luster, metallic luster or the glitterness of gold is long lasting. But however, when you go to the nanoscale, my dear children, nano gold particles are so much reactive. Okay, it's because during the reaction of the particles size, right? During the reduction of the particle size, I mean, when you are moving from macro to nanoparticles, right? The reactivity is getting increased. Here the reactivities keep getting increased because of the increasement of surface area of those particles. So during the increasement of surface area, the reactivity is getting increased. Because of that, special properties, special physical properties and also chemical properties could be observed within the nanoparticles. So those are the parts that we discussed in the earlier chapter. This is just a brief, right, about the previous chapter. Now, my dear children, we are going to start a fresh new chapter in here. Here we'll be mainly focusing about how to observe these nanoparticles, the way of observing these nanoparticles. When I was starting the lesson part, I told you that, right, when we are discussing about the introduction and the history, we discussed that in order to observe these nanoparticles, right, we should have to have an electron microscope, which is the most powerful microscope built by the humankind, right? The most powerful one. Even by using an electron microscope, we can observe somewhat larger molecules as well. Up to molecular level, we can observe, right? Sometimes even some larger atoms can also be observed. Some large ones, not smaller ones, but some larger ones can also be observed, right? So like that way, there are several kinds of electron microscopes. We'll be focusing about those things. So let's see what are these electron microscopes then. So here it is given how to see the nanoscale, how we can observe the nanoscale. Okay, so your fingers are millions of nanometers long. So it is no good trying to pick up atoms and molecules and move them around with your bare hands or see them using common optical microscope. That would be like trying to eat your dinner with a fork 300 kilometers long. So it is given that, right, by just reading out this thing, you can get a certain idea about the sizes of the particles, nanoparticles, right? So you can use your fingers, right? You can use your fingers in order to move certain items only. In simple, my dear children, you can use your fingers to move the items or the things which you can observe from your naked eye. No? If the objects are not observable from naked eye, then you won't be able to move them here and there. Nanoparticles are also the same. If you take a nanoparticle, my dear children, these things will not be able to observe from your naked eye, not even from normal optical microscopes. We discussed those things on the previous chapters, right? Can you remember? So, therefore, we won't be able to manipulate these particles according to our wish, because we won't be able to observe those things. So, we won't be able to manipulate those things from our bare hands, right? So in order to see those things and manipulate these things, we'll be needing special instruments. So it's like, now here it is given, right, a metamorph, like, can you see? Here it is given, it's like eating your dinner with a fork like 300 kilometers long. It's not possible, no? If the fork is like 300 kilometers long, we won't be able to even, let's imagine that we are we are applying a certain force so that we can lift it up somehow. Even though we are going to lift it up, we won't be able to, right, grab our food by using that fork, because the food item is much smaller than the fork. Okay, so here by just looking at the sentence, you will be able to get a certain idea, because here the size of the particle is compared. Okay, so my dear children, now let's take a nanoparticle. Now manipulating a nanoparticle by using your bare hand means like eating your dinner or any other meal by using a 300 kilometer fork. It's not possible at all. Okay, so in order to manipulate these things, move these things here and there, nanoparticles, then what we have, first of all, we have to observe these things. So here it is given, scientists have developed electron microscopes that allow us to see things on the nanoscale and also manipulate them. Now, scientists have developed things or certain instruments that can be used to manipulate these nanoparticles and also to observe these things. So there are three types of electron microscopes which can be used to observe these nanoparticles. So let's see what are those types. Number one given, atomic force microscopes, AFMs, right? AFMs. So atomic force microscopes, AFMs, right? AFMs. Then number two, scanning probe microscopes, SPMs, right? Scanning probe microscopes. Then number three given, scanning tunneling microscopes, STMs. So these are the types of electron microscopes, right, which developed by the scientists in order to observe, right, these things. These things means nanoparticles. So like I said, my dear children, these nanoparticles are very tiny. So they use a beam of electron to observe. Sometimes they use anti-electrons. These anti-electrons are also referred to as positrons. So you'll be learning about these things when you go further with the grades, my dear children. I'm not going to explain about those things. Okay. So I think you have heard about the electron now, right? So like that way, there is another particle which is referred to as a positron. So positron is a particle that has a positive charge. However, the mass of the positron is equal to 0, or else 1 over 1180 or 1 over 1840, okay, of a size of a proton. So we comparatively to a proton, we take that one as 0. The mass is 0 in a positron. But however, when you take the charge of it, charge is not negative but positive, okay, opposite of the electron, same as the electron but the opposite of electron, positron. So like that way, they use different kinds of particles in order to operate these electron microscopes, my dear children. Okay, so you'll be learning about these antiparticles when you go with the further grades, my dear children. I mean, not go O levels, when you have to when you complete your A levels and you go to several university colleges. If you do physical subjects, right, physics subjects, then you'll be able to learn about these things, right, about the micro world, right, about the quantum world, right. Okay, so these are the three main types of microscopes, the electron microscopes that we can observe, right. So the first one is AFMs, second one SPMs, third one STMs. Atomic force microscopes, scanning probe microscopes, scanning tunneling microscopes. Okay, right then. So here is given the first and the foremost image, the electron microscope. Then you can observe over there the atomic force microscopes. Then here you can observe the scanning tunneling microscope. So these are the images regarding to these special kinds of microscopes. So here you use a special kind of a computer to observe the image of, right, to observe the image of the certain substance that you are looking at. Okay, so by using the special instruments, right, special structures and special instruments, you can move or manipulate these nanoparticles. Okay, the other thing is that, my dear children, these instruments are very expensive, right. Only few, when you take Sri Lanka, only few, right, like less than 2, less than 5, like very few. Okay, very few electron microscopes are available in our Sri Lanka, very few. So electron microscopes are that much expensive, too much expensive. Okay, only very few are observable in Sri Lanka, my dear children, right. So these are the electron microscopes which can be used to observe nanoparticles then. Okay, so now, my dear children, we have learned how to observe the nanoparticles by using the electron microscopes, right. So over there we just discussed how to observe, that's it. We're not discussing about their functions, I mean, like how to observe in deeper detail, by using deeper details. But however, like we have got a certain idea about it, that's it. Okay, so up to your level it's enough. When you go further when you go with further grades, you will get to know about these substances and these materials and instruments, my dear children. Okay, so now we are going to start a fresh new part which is referred to as nanomaterials, right? Nanomaterials means, my dear children, here what are the materials that we can use to build up nanoparticles in our day-to-day life, right? To do our day-to-day life activities, what are the nanoparticles that we can use? And from those nanoparticles, what are the special kinds of materials that we have built? So we'll be discussing these things under this nanomaterials part. So let's see first of all. So key to developments related to nanotechnology innovations are based on availability of nanomaterials. So first of all, my dear children, we should have to have these nanomaterials in order to build up nanoparticles, right? That means in order to extract these nanoparticles and to utilize them in a different place, we should have to have that kind of a certain. Now, all of the materials cannot be used to take nanomaterials or nanoparticles. All of the matter, or in simple, all the elements in our environment will not be able to utilize to take these nanoparticles. There are certain substances, there are certain materials which we can use, there are certain elements which we can use to get nanoparticles. Okay, all the things are not, right? All the things cannot be used to get these nanoparticles, my dear children. Okay, I hope that you got the idea well. So therefore, the specialty here is that we should have to find out materials or elements which can be used to get nanoparticles. Okay, so here it is given. The availability of the nanomaterials are very important to build up these nanoparticles using nanotechnology. So over there, mainly we are using what? Carbon-based nanomaterials. Okay, carbon is a very special element in our environment. If there is no carbon, so we won't be able to live without carbon, because we, organisms, each and every organism is a carbon-based substance. Carbon is the main component. Carbon is a main component contained in our body. All the living structures, all the living components, all the living molecules, right? Actually, their molecules are not living, but the things which are living in simple cells, my dear children. Now, when you go to the structure of the cells, there are different structures made by different molecules, no? So, the molecules which creates the living material are mainly made up with carbon. Okay, molecules which used to create living materials are mainly made up with carbon. You know that the main living material or the main living molecule, right? It's not actually the molecule. Let's see, let's refer it like this. The main molecule which used to create living molecules or living materials are the nucleic acids. Okay, nucleic acid and amino acids. So these things are created mainly by utilizing carbon. So carbon is a very important substance, carbon. So like I said, carbon, if there is no carbon in our atmosphere, in our environment, if there is no carbon in our environment, then there is no life, right? Life on earth will not thrive if there is no carbon in it. Remember that. So carbon is a very important element. So my dear children, even for creation of the life, carbon is important, and also for the nanoparticles, we mainly use carbon, right? So carbon is the one which can be mainly used to create nanoparticles and nanosubstances. So let's see. Out of many available nanostructures, carbon-based nanostructures are among the most exciting nanomaterials, right? So they can be rod-shaped a football shape or thin sheets. So these carbon-based nanomaterials are much popular, my dear children, because it's very easy to make substances by using these carbon-based nanomaterials. So these carbon-based nanomaterials, when you go to the structures of them, right, when you take these nanomaterials, their structures are like, plain surface, or else you can see in here like thin sheets. Then sometimes they have a football kind of a shape. Then sometimes they have like a rod shape. Okay, so like that there are several nanoparticles which are made up with carbon. Okay, carbon based nanoparticles. So you are given here with a figure, image of a human hair under electron microscope. Okay, so as you can see, this is like, here it is given 10 micrometers. Okay, it's even not in the nanoscale, right? It's even not in a nanoscale, my dear children. Okay, so here, now let's see. Okay, now this is just to get an idea about the nanoparticles, my dear children. So if you go to the nanoscale, then you might not be able to identify the things contained in that hair, right? So this is in microscale. So when you observe it from the microscale, you can see an image like this, right? So forms of carbon. Then, my dear children, you are given with the topic forms of carbon. The forms of carbon means, my dear children, the types which the carbon element is available in our environment. Actually, carbon is an element, right? It's a polymorphic element, or else it shows allotropy. What do you mean by allotropy? What is allotropy? Polymorphic. So polymorphic or allotropy means, my dear children, if you take a certain element, usually a certain element is available in our environment only as a one form, no. Usually that's the way how elements are behaving in our environment. In simple, when you take sodium, sodium is a metal. It can be extracted by using the electrolysis process. So it is a metal, right? Usually in our environment, right, sodium is available as not a metal, but however it's going to combine with other different substances to make compounds. So I'm not talking about those compounds, I'm just talking about the element sodium. Usually when you extract a sodium element, it is observed as a metal. When you take copper, now copper is always available in our environment once again as a metal, right? Like brownish color, right? Brownish color related substance, right? That's copper. Always it is available as like brownish color metallic substance. That's it. That is it. If you take aluminium, the same thing can be observed. However, the color is somewhat getting changed, right? The color, like silver, it has a silvery nature, right? It has a luster. I mean, like they have the properties of the metals. No, as aluminium is a metal. So all of these substances, when you take all of these substances, if you go to the elemental form, the elemental form of these substances is same to same. We won't be able to observe aluminium. If you go to the elemental stage of the aluminium, it is always a metal. So it is available as a metal. If you go to the elemental stage of the copper, once again you can observe it as a copper metal. That's it. There is no any other. Okay, there is no any other. If it is a metal, then it is a metal. We won't be able to observe the same element as a non-metal or any other substance. But however, when you take polymorphic substances, or else substances that show allotropy, elements that show allotropy, now in these substances, my dear children, there are some substances which are made up with this particular element, okay, made up with this particular element, but however the properties are way more different. Okay, properties are way more different. That means in simple, my dear children, when you take an example like copper and carbon, Let's imagine that in a certain place there is 10 atoms of copper collected each other. So if 10 copper atoms are collected each other, right, then in that place also we can observe copper metal, that's it. If 100 copper atoms are collected to each other, then over there also we can observe only copper metal, but somewhat lengthier one because there are somewhat more atoms. If 1000 atoms collected to each other, copper, okay, if 1000 copper atoms are collected to each other, then in that place also we can observe copper atom, but however somewhat lengthier or somewhat heavier one, as it is going to contain more amount of copper particles. However, if you take carbon, if carbon is going to bond with 3 nearby carbon atoms, okay, if carbon is going to bond with one carbon atom, right, is going to bond with 3 nearby carbon atoms, then my dear children, carbon is going to create a special structure called graphite. I think you have heard about the graphite, right? In your pencil tips, that pencil tip is made up with graphite. And in electrolysis, my dear children, or in electroplating, we use graphite rods, inert rods, as inert electrodes. Can you remember? So those things are graphite. In here, carbon is bonded with 3 nearby carbon atoms. Okay, 3 nearby carbon atoms join together to create graphite. If 4 nearby carbon atoms, if 4 carbon atoms are going to collect each other, in that case, my dear children, that particular, right, the previous one was graphite, no? Now, over there, 3 carbon atoms with 3 carbon atoms, no? If it is going to change, right, if it is going to change into 4 carbon atoms, then, my dear children, diamond is getting created. When you take diamond and graphite, these two are made up with a same substance or same element, which is carbon. However, in graphite, there are 3 carbon atoms joined each other. In diamond, my dear children, 4 carbon atoms joined each other as a network. Okay? Even though their, collection ability or bonding ability or the bonding nature is getting changed, the count of atoms is getting changed. However, the elemental composition is same, no? Carbon. Both the things are made up with carbon. Even though they are made up with carbon, according to the number of carbon atoms which are bonded to each other, the physical and chemical properties of the substance is getting changed dramatically. However, these things can only be observed only for certain substances. If you take the first 20 elements in our periodic table, right, from hydrogen to calcium, those are the ones which you have learned, actually, which you are going to learn, right, if you take first 20 elements, okay. So within these first 20 elements, my dear children, we can only observe these kinds of polymorphic substances, like only there are 3 examples. One is carbon, another one is sulfur. Sulfur is also polymorphic. We can observe white sulfur and also yellow sulfur, right? White sulfur and yellow sulfur. Both the things are made up with sulfur, but however, according to the structure and the bonding nature, the colors are getting changed with their physical and chemical properties. The other one is phosphorus. There is phosphorus and there is phosphorus, which is also a polymorphic. That means it is also going to show different kinds of natures according to the bonding natures and the count of phosphorus atoms present. Okay, so there is one thing called white phosphorus and there is another thing called red phosphorus. Usually, when you take matchsticks, okay, when you take a matchbox, so on the surface of the matchbox, you can observe red phosphorus. Basically, it is made up with mainly by using red phosphorus, the surface of the matchbox, right, which you use to, rub the match head on that particular surface? No. So that brown color, brownish color nature or reddish color substance is made up with mainly from red phosphorus. So red and white, like that way, phosphorus also going to show polymorphic nature or else allotropy, right? So these are the substances which show allotropy, my dear children. So polymorphic means, remember, they are made up with same element, but however their structures are changed according to the number of atoms present in it. So these are only available for few elements, right? So I have given you 3 examples for these things: carbon, sulfur and phosphorus. Okay. So in carbon, my dear children, carbon exists as mainly 2 distinct polymorphs. Okay, polymorphs or allotropy forms. So there are 2 allotropy forms. Those 2 are carbon graphite. So graphite carbon, and the other one is carbon diamond. So then here you are given with an activity. Let's see what is the activity then. Collect the information about carbon graphite and diamond. Discuss them in classroom. Okay. Right. So my dear children, can you see here? Actually, the structures of carbon graphite and carbon diamond is given here. This is diamond. Like I said, when you separate a certain level, okay, I'm going to separate a certain level. I'm going to box it and show it to you now. See, how many carbon atoms are there? 1, 2, 3 and 4. 1, 2, 3, 4. So there are 4 carbon atoms. So like that, there's these kinds of units are keep getting collected together and together in creation of diamond. So like I said, can you remember? 4 carbon atoms are bonded each other to create the structure called diamond. I mean, 4 means, my dear children, within the building unit of this diamond, structure of diamond, there are 4 carbon atoms. Okay. Within the building unit of diamond, there are 4 carbon atoms. So like that way, these building units are keep getting collected each other to create the structure diamond. So this is diamond. Right. So my dear children, this is the first and foremost polymorphic item of carbon, which is diamond. Okay. So diamond is made up with bonding of 4 carbon atoms each other like this as a structure. So what are the other features? Now here the activity we are discussing. Okay. I'm going to discuss with you guys what are the special properties of these 2 polymorphs of carbon. Okay. Right. So this is the first one, the diamond. So I told you how the diamond has been created with the collection of carbon atoms. Now let's see what are the properties, special properties of diamond. You know that the diamond is the hardest material, the densest material, densest or the hardest naturally occurring material which we can observe. There are other substances which has higher density and the which is having higher hardness in our environment, but however those things are artificially created, man-made things. Naturally created hardest and the densest substance is diamond. We have learned these things since grade 6 to now. Okay, can you remember when we are discussing about the hardness factor, right? We discussed about the diamond in grade 6, my dear children. So hardness is coming because of the strength of the nature, strength of the bonds. So like I said, my dear children, you know that 4 carbon atoms are bonded each other in creation of diamond. No. So therefore this bonding structure is much stronger. So therefore diamond is very hard. It's highly resistant to scratches and wear off. And the other thing is that diamond has a special glittery nature because of the higher refractive index. It has a very high refractive index. That means my dear children, if you send a certain light beam through diamond, it's keep getting refracted. Okay, the refraction ability is very high in diamond. It has a very high refractive index. Okay, so my dear children, diamond is much expensive because of these properties. And to create diamond, my dear children, okay, to create diamond, carbon should have to go in immense kind of a pressure. I mean, like when you take like graphite, okay, when you take like, no need to take graphite, you just take like charcoal. You take charcoal, and if you know that charcoal is made up mainly with carbon, so you take charcoal, and if you can give it up, like if you can provide enough pressure with suitable conditions, then you can create then you can create this diamond. However, that pressure is like very immense. Okay, so in like in our day-to-day life, we won't be able to provide that kind of a pressure to the charcoal. Okay, however, theoretically, if you can provide with a necessary amount of pressure, then we can create diamond from charcoal. It's because that the arrangement of the structure, the arrangement of the bonds is getting changed when providing pressure, right? When providing pressure to the carbon. So, my dear children, now that's why diamond is very much expensive. Naturally occurring diamond is very much expensive because it's very rare to find. So, to create diamond, right, we won't be able to observe diamond in like each and every place. So, we have to dig very deep, right? So, you know that our earth, when you go certain levels of the earth, the pressure is keep getting increased. So that pressure is the reason for the creation of diamond. Okay, right? So diamond is that much rare and very expensive, and also it has high density and high refractive index, and it's a hardest naturally occurring substance which we can observe in the environment. These properties are observed because, my dear children, 4 carbon atoms, okay, 4 carbon atoms can be observed within the building unit or the building structure of the diamond. So this is diamond. Actually, diamond cannot be used to get, right? I mean, like sometimes it can. However, the diamond is not more often being used to get these nanoparticles of carbon. What is the most common nano substance, right, or most common substance to make nanoparticles in carbon? The second one over here, what is that? Graphite. Okay, now I told you the properties. It's your responsibility to take them down and note them down, my dear children. Okay, I have discussed each and every properties related to the diamond, first one, and now I'm going to discuss the second one, the graphite. Okay, it's your responsibility to study these things very well. I'm going to explain each and every content, somewhat even way more than that. Okay, so it's your responsibility to follow up with these things and to note down if there are any special things regarding the lesson part. Okay, right. So the second one, my dear children, this is the first one, diamond. So I have explained their special properties and their special things related to the structure, according to the structure. Now I am coming to this graphite. Okay, graphite. So graphite, my dear children, is somewhat different than that. If you take graphite is somewhat different than that. Okay, so in previous case, can you remember, one carbon atom is going to bond with 4 nearby carbon atoms? No, actually, when I'm going to take this structure, it should be one like here. Now this is the structure. This is the completed one. As you can see, there are some arrows given here. So if you take one carbon atom, it has 1, 2, 3, 4 bonds. I mean, like it's going to create 4 different, right, structures, 4 different bonds. Okay, earlier, like I have boxed it and I show that I have shown that there are 4 carbon atoms joined together. But however, 4 carbon atoms means, my dear children, it is going to create 4 bonds like this. There are 4 bonds. Okay. So there are 4 bonds. Let me take you to here so that you can observe it very clearly. Okay, now I'm going to take a structure from here, from the middle. If you are going to take it from the middle, then you can clearly observe it. Okay, see the structure. Let's take from here. So I'm going to highlight and show. Okay, observe. Take this one. Right? This one now. So I'm going to erase the unnecessary parts now. I'm going to erase and show the unnecessary parts. Let's erase this one. The unnecessary parts, I'm going to erase those things so that you can observe it very clearly, the structure. Right, now I think you can observe it very clearly. See, this one, this particular area which I have colored with red. Can you see that? This one carbon atom is going to bond with 1, 2, 3, 4 nearby carbon atoms together. See, there are 4 nearby carbon atoms together. Each and every carbon is going to bond like that way with 4 nearby carbon atoms together in creation of diamond, my dear children. See, now you can see it very clearly if you take the structure. 1, 2, 3, 4, right? 1, 2, 3, 4. There are 4 bonds. Each straight line over here is going to show one single bond between carbon atoms. Okay, so this is how carbon diamond is created. There are 4 carbon atoms bonded together with single bonds. 1, 2, 3 and 4. Okay, there are 4, right, bonds. Okay, 4 bonds. So here, however, there is a certain difference. What is that difference? If you take one single carbon atom over here, one single carbon atom, okay, if you take one single carbon atom over here, you take any carbon from here, let's take this one. Count how many bonds are there. Let's take this one, this red colored one. Now let's count how many bonds are there. See, 1, 2, 3. There are only 3 bonds. Can you see that? If you take another one, let's see, we'll take one from here. See this one. 1, 2, 3. There are 3 bonds. If you take this one, see how many? 1, 2 and 3. There are 3 bonds. So in graphite, my dear children, right, in graphite, you can observe 3 bonds, not 4, but 3. Okay. In here, you can observe 4 bonds, but here you can observe only 3 bonds. 3. So 3 bonds can be observed within carbon. That means one carbon atom is going to create 3 bonds with 3 other nearby carbon atoms. Okay. There is another bond. Okay. There is another bond. There are 4 bonds. But the 4th bond is represented as a broken line. Can you see that? See, here 1, 2 and 3, and the 4th one is given as by dots. Can you see that? That means, my dear children, in graphite, the carbon is arranged as into layers like this. Layers. So this is a one layer. So this layer is bonded with this particular layer with very weaker bonds. Not a stronger bonds, but with weaker bonds. That is why it is represented by using broken lines. However, that kind of a structure cannot be observed within here, the diamond. So that's why diamond is much harder than graphite. Graphite is somewhat smoother, and graphite has that ability to slide past each other. You know that when you are writing by a pencil, actually what happens here is the pencil tip is sliding past on the book or whatever the paper that you are going to write it down. And if you take pencil powder, right, powder of the tip of the pencil, I mean graphite powder, when you take some powder and if you rub it against your finger, you can see some kind of a like slippery nature. It's mainly because of the structure of this graphite. Okay, graphite is arranged to as layers like this, and within these layers, if you check one certain carbon atom, it has three bonds with nearby carbon atoms. Three bonds with the nearby carbon atoms, right? The fourth bond is very weaker. Fourth bond means the bond between two layers is very weak. So this weaker bond has the ability to slide past each other, right? That means these layers, as these layers are weakly bonded to each other, these layers have the ability to slide past each other. So therefore, graphite has a lesser density than diamond, and also it has lubrication ability. What is lubrication? That means, my dear children, it has a slippery nature. Okay, it has a slippery nature. So I think you have heard about engine oil and about grease. Those things are carbon-based materials made up with carbon-based nanomaterials. Specialty here is that upon creation of those particles or those substances, we use graphite. Because of that slimy or the slippery nature of graphite, we use these things to create lubricating substances like grease and engine oil and other kinds of different oils, which is applied to certain types of machines like gear oils, then brake oils. All of these things are made up with mainly from utilizing carbon graphite substances, because it has the lubricating ability. As the layers are weakly bonded, these layers have the slide passing nature with each of the nearby layers. So therefore, my dear children, right, we use this graphite in making lubricative items. So the properties: carbon is bonded with 3 nearby carbon atoms, or else if you take one particular carbon atom, it shows 3 bonds with other carbon atoms. The fourth bond, that means bond between 2 layers, are very weak. Okay, so I forgot to tell you one another thing. Here the graphite is created, right, or graphite is created arranging into layers like this, by arranging into layers. Okay, so within one certain carbon atom is going to create 3 bonds with nearby carbon atoms, and these graphite are arranged to as layers. These layers are having weaker bonds, so layers has the ability to slide past each other. Because of the sliding past ability, graphite has lubricative properties. Okay, lubricative properties. Hardness of the graphite is lesser than diamond, and also the density of graphite is lesser than diamond, right, my dear children? So these are the special properties of graphite then, graphite and diamond. Even though these two are showing different properties, both of them are made up with carbon, my dear children. Both of these substances are made up with carbon. Only thing which is getting changed is the bonding nature, right? So I hope that you got the idea about the diamond and graphite. So we have collected the information. Actually, I have collected information, so I have given to now you guys. So it's your responsibility to, it's your own responsibility to get these ideas thoroughly. And if you have, right, if you have the ability to note it down, right, so that you can remember it quite well. These things are very important when you are going with the further grades, my dear children. Okay, so we have collect out the information about carbon and graphite, right? Carbon, graphite, and carbon diamond. So we have discussed it. So I hope that you got the idea about the properties related to diamond and graphite, right? Then, so let's head on to see the next one. So next fresh new topic is about what? The graphene. Graphene, right? Graphene. So graphene is a very important nanomaterial which is made up with carbon. Very much important. Okay, nanomaterial which is made up with carbon. So before I'm going to explain about the graphene, let me explain about graphite once more. I told you that graphite has certain layers, and also graphite also have the ability, right, or else graphite has another property which is referred to as the, that lubricative nature. It's because it's because of that those layers can slide past each other because of the weaker bonds, right? Graphene is a layer, one single layer of that graphite structure, one single layer, that's it. Okay, one single layer. So as you can see here within the given figure, this is graphite, no, this is that weaker bond, see? So this is one single layer. So when you remove one single layer, then you can create what? Graphene. This one single layer is referred to as a graphene layer. So let's see. Graphite has layered structure, and scientists have attempted to separate a single layer from the structure for several decades. It was one of the significant achievements in science when single layer of graphite was peeled off by two scientists, Andrew Ghem and Konstantin Novoselov, right? So Andrew Ghem and Konstantin Novoselov were the first two scientists from the University of Manchester to remove this kind of a layer from graphite, my dear children. So scientists have tried this thing for decades in order to remove a certain layer from graphite, because we can utilize this layer, right? I mean, like, we can, you can take one certain layer, keep it like this, you can take the other layer and keep it over there, then you can create like whole heap of like beehive kind of a thing, structure. And the other thing is that these layers are flexible. You can, fold it to anywhere, and you can even take the shape and, curve it down to create a tube. So like that way, there are different kinds of applications in graphene. That's why it is very important to remove a certain layer, right? So scientists have tried this thing for decades to get a certain layer and to remove it, and to reinforce these things upon creation of different kinds of structures, different kinds of structures. However, even for trying for decades, right, they haven't got any idea about separating this thing. But however, right, these two scientists, right, Andrew Ghem and Konstantin Novoselov, right, these two guys finally found out how to remove a graphene layer. Now, the funniest thing in here is that they just needed only a duct tape, only a cello tape. You just, grab the cello tape, paste it, drag it, that's it. So that's it. That is how to remove this graphene layer. It's very simple. However, scientists have tried several times by using different other, so much harder methods to remove a graphene layer, but actually the solution was there all along, even though they are trying for different other kinds of advanced stuff. In the same way, my dear children, our life is the same, right? Now sometimes we, you know, when you take, let's take like a question paper. So sometimes a straightforward answer is going to come. Okay, straightforward answer is going to come in a question paper. You know the answer is correct, and you also know that it's quite easy. Then sometimes you might overthink. This won't be the answer because now we are in grade 9, so we won't be receiving this kind of questions because the answer is pretty much easy, right? So you might think, and you might sometimes overthink, and you will go for a different answer by removing that simplest, easiest one, and sometimes you will, right? What will happen? The question is now totally wrong. So this is applicable in our normal life as well. Sometimes, my dear children, the solution for the problem is there. We can see it within our own naked eyes, but however, we are not using it because we are going to hesitate to use it as it is very simple. However, the answer is there. That's the answer. Okay. The same thing is observed over here. For decades they have tried, but however, they were needed only with a certain duct tape. That's it. So let's go for the lesson part then once more. So they received the Nobel Prize in physics in 2011. So see, actually now you know that the nanotechnology took off like in 1980s for the first time. But however, it took like, decades in order to remove this graphene layer. Like in 2011, see, in 2011, these two people got the Nobel Prize in removing of a graphene layer from graphite. See, so they received the Nobel Prize for the physics in 2011 for this groundbreaking innovation. It was a serendipity event in the history where they needed only a scotch tape and a piece of graphite for this innovation. So like I said, my dear children, they were needed with only a scotch tape and just a piece of graphite. You just, take the scotch tape, paste it, then drag it, then you can separate graphene layer. Very simple. However, they have tried it for several times. They have tried for many times. Then they have used the simple method after that. Okay. So it is a groundbreaking, right? It's the groundbreaking innovation as well. Actually, it is because it's a very simple method. However, the application of these graphene layers are applied in very, very, like when we take nanomaterials, mainly we take nanomaterials which are made up with graphene, my dear children. So the applications are immense. So they took the Nobel Prize, right, for this innovation in 2011 therefore. Okay, right. So this is about the graphene then. A layer of graphite, one certain layer of graphite. Okay. So as you can see here within the figure also it is given like that way. Graphite is arranged as several layers. So we remove a certain layer like this and we arrange into a certain sheet like this. So this is graphene. Okay, graphite, graphene. So graphene is a single layer thick graphite sheet. Okay, graphene is a single layer thick graphite sheet. That means about 0.5 nanometers thickness. Half of a nanometer. Thickness is half of a nanometer. This much thickness. This is very heavy, heavily thick. That's why even we can observe graphite from our naked eye. But however, graphene cannot be observed from naked eye. One graphene layer cannot be observed because the thickness is around 0.5 nanometers. Okay. Then has unique properties due to high surface area. Now my dear children, you know that if they have arranged like this into layers, the surface area is reduced. But if you can arrange it like up to to have like this kind of a structure, it has wider surface area. It's like you take a piece of cloth and fold it into several pieces. Now the surface area less, no, because one surface is placed on another surface, no. Over there, even though the size is getting reduced, the surface area is less. Why is that? Because, my dear children, one surface is contacting with the other surface, so the surface area is definitely getting reduced, right? Now what will happen? Now we are going to remove that structure, and we're going to keep it on empty space by unfolding it. Now it has a bigger surface area because all the surfaces are getting contacted, not getting contacted each other. All the surfaces are not getting contacted each other. It's getting spreaded here and there. So it has a wider surface area. So what our idea is to take these layers and to arrange it like into a sheet like this. So it has a wider surface area. Okay. So it is highly flexible while demonstrating very high mechanical properties. Now the other thing is that this layer is highly flexible. Like I said, can you remember? I told you that this can be folded down into any shape we want, like a piece of cloth. Okay, we can fold it down to any shape we want. It's very flexible. However, it's very hard to tear out this thing. Okay, same as a piece of cloth. It's very flexible. We can, fold it to here and there like to any shape, but we can't tear it off. It's very difficult to tear off. We should have to cut it by using a different method, or else we have to, make a hole and, tear it down like that way. We have to apply any kind, heavy kind of a force in order to remove this thing. Okay, in order to remove and tear off. So graphene is like that. The thing is that the graphene is showing even more hard nature, right? Even though it is flexible, the strength of these layers, the strength is very high. It is saying that, right? It has been, to compare the strength or to show the strength of graphene, right? There's a metaphor like this. Now you can keep an elephant on the top of this graphene layer. Even though the elephant is being placed on this graphene layer, this layer is not getting broken. That much of a strength can be observed, okay, within graphene. However, it is flexible, right? So it is strong and also flexible. And the other thing is that, my dear children, lightweight, right? It's also lightweight. You know that piece of a cloth, lightweight, no? So in order to be a heavy one, the surface area should be very high. I mean, like we have to take like several meters long piece of cloth in order to get a very heavy one. Okay. So there are different physical and mechanical properties that we can observe within the graphene. So it is highly flexible while demonstrating very high mechanical properties. Well, it also shows unspected electronic and electrical properties. It is considered as the material that has the potential for revolutionizing the next generation flexible electronics. So, my dear children, so you have heard about the flexible mobile phones, tablets, right, and flexible televisions and other electronic equipments. All of these things are now a reality. Okay, it's mainly because of this graphene. So it's been observed that, so I told you that this is flexible now. So it has been observed that this graphene is also showing different conducting abilities, unspected conducting abilities of electricity. You know that usually graphite is a good conductor of electricity. However, unspected conducting abilities can be observed within graphene. So it's a revolutionizing material which is used in electronic industry. Okay, actually, because of graphene, most of the electronic components have been developed in our nature, right? are pretty much advanced ones. Pretty much advanced, like I said, foldable ones. Those things are mainly created based on these graphene, my dear children. Okay, so I hope that you got the idea about graphene layers and their special properties. Okay, right then. Right, my dear children. So we have discussed about the things related to the carbon-based nanomaterials. Okay, we have discussed about the carbon-based nanoparticles, my dear children. So I hope that you got the idea about these carbon-based nanoparticles very well. Okay, over there we discussed about the diamond and graphite. So graphite is the most important carbon-based particle or carbon-based substance that can be used to create, right, these nanoparticles. So graphene is the structure, or the graphene is the one layer of graphite which is being heavily used in our normal industrial markets to create electronic substances and also nano substances. So these graphene layers are highly flexible while it is showing different kinds of special mechanical properties, and the strength of this layer is very high also. However, it is very flexible and lightweight. Okay, my dear children. So these are the things that we have learned within this lesson part related to the nanoparticles and nanomaterials. So in our next chapter, my dear children, we are going to focus about the nanomaterials which are being constructed by using this carbon, right? So however, we'll be learning those things about those special kinds of nanomaterials and nano structures within our next chapter, my dear children, right? So up to now we have discussed how these carbon nanoparticles have been utilized in creation of nanomaterials. So let's discuss about those nanomaterials in our next chapter then.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.